Hello students, welcome to lecture number 17. Now today we will be going to discuss regarding reinforced concrete slab, that what are the various type of slabs, what are the codal provisions regarding the analysis as well as design of slab, and what are the parameters which we have to consider, what are the guidelines, recommendations of different type of slabs which we are going to discuss today. So this is a continuation to the design of RCC structures, that is limit state methodology which we are adopting here, and let us go through details from lecture number 17 onward. So first of all, let us understand what is basically RC slab system and what are the various relevant points which we have to keep in mind while doing the analysis as well as design of the slab. So let us try to understand the definition part, that how we can define a slab. So reinforced concrete slab are large flat plates. So they are just like flat plates, and they are supported on reinforced concrete beams, or either can be supported on walls or columns, by masonry wall, by structural steel beam or column, or by ground. So that means here what we are able to understand, that reinforced concrete slab are just similar to large flat plates, and they can be have a different type of support conditions, and either they will be simply supported or they have a fixed type of support, as well as they may be directly placed on the walls as acting as a simply supported type of slab, or they may be continuous type of slab, that means having more than two supports, having more than one span. So that we are going to discuss today. Slab, as everybody is aware, they are most widely used structure element whose thickness, so main criteria is thickness, whose thickness is considerably smaller than any other dimensions. So here thickness will be also termed as the depth of the slab. So depth of slab or thickness of slab is considerably smaller as compared to its other dimensions. That means two sides of the slab, they will be having two type of spans based on the support conditions, whether the slab is supported on two sides or either it can be supported on four sides. Now they are frequently used as floors and the roofs in case of buildings. So floor is a one type of slab, and a roof is another type of slab, you can say. So they are termed as slab. Decks in the bridges, they are also come under the definition of the slab. And the top and bottom of tank, if there is any water type of tank, then the base of the tank will also be a slab, as well as top, that is covering of the tank, is also a slab. So slabs can be directly supported on soil, just like staircases, etc. So they can be directly supported by soil, or they can be supported by any type of beam, walls, etc. So whatever we have discussed in first point. So that means supporting system of slab can vary. You can directly place it on the soil, or you can just place it at some height with the help of columns or beams. So either there may be a wall type of construction, so you can place slab directly on two walls. That means there will be that type of slab will be supported by walls. Now what they do, they support and transmit load to the walls. So that means whatever the load coming on the slab, that can be transmitted to the walls, or if they are supported by beams, then load will be transferred to the beams. And sometimes we can say that they can transmit the load directly to the column by flexure, shear, or torsion, which you will be able to understand in the coming lectures. Now another aspect which is a very important aspect of a slab, they have very large volume, and hence the mass of the slab may attract large lateral forces which may be due to earthquake or any type of acceleration forces which can be induced. Slabs may be having different type of shapes as well as support condition as we discussed. So they have different type of slabs based on the shapes. They can be solid slabs, they can be rib type or waffle type of slabs. So our main focus will be on solid type of slab which we are going to discuss in this subject. Now in continuation, depending upon the load carrying behavior, that how slab is taking load and how various type of movements are acting on the slab, they can be classified into two ways. Number one, that is a one-way type of slab, and the second type of slab is two-way slab. So what is the meaning of one-way slab, and what is the meaning of two-way slab, and how they are differentiated? Let us going to discuss now. And the choice of slab for a particular structure will be largely depending upon the economy. That means economies and consideration, uh, and it depends upon buildability, that how easily you can build and what will be the methodology of construction, and loading condition as well as length of the span. So accordingly, we have to decide that what type of slab we can take into practice based on all these parameters. Now, a slab is generally designed as a flexural element, just like a beam. Here, what we have to do, we will be taking a strip of 1 meter width. That means if a slab is suppose having 10 meter long, then we will be designing 1 meter strip of the slab, and that information or reinforcement, whatever we are able to get, that will be uh, carry forward throughout the slab. That means whatever be the reinforcement designed in 1 meter width, that will be taken throughout the slab. So even though it is cast in one piece and not in strips of unit width, but methodology of deciding or designing the slab is by taking 1 meter width. So that means it will be just like a beam having some particular depth as well as having width is equal to 1 meter. So economy of the slabs largely depend upon the thickness, because it any slab may be like this. It may have huge length of the span, and ultimately, if you are taking the depth of the slab, suppose this is just like a slab, so this depth of slab will be directly influencing the volume of the slab. That means how much material is required, and accordingly economy will be uh, checked. So whatever be the cost of the slab and the construction material which we have to require, that directly depend upon the thickness of the slab. So prime factor here in slab is thickness is one of the important factor which we have to take into consideration. Now for design purpose, slab can be taken equivalent to rectangular beam, as I have already explained, that it is just like a, you can design it as a, you have designed a beam, maybe just like a singly reinforced type of beam. So we can design it as a rectangular beam, but what here changes is the width. Generally, in case of beam, we take 300 or 350 like that millimeter, but here we are taking the width of the that particular strip as 1 meter. So it can be just it is just like a rectangular type of beam having width is equal to 1000 millimeter 1 meter, and whatever be the depth. So it will be just like a rectangular beam. Now as slabs we are going to discuss, the slabs are thin compared to the beams, having depth comparatively lesser as it is comparatively lesser as compared to the depth of the beam, you may have designed various type of beam, and their width generally varies from 400 for 450, 500, 550 like that. But in case of slabs, you will be finding that most of the slabs are having the depth range, sorry, thickness range from 150 mm to 200 or 220 mm, just like that. So the serviceability limit state of deflection is normally critical in these type of slabs, and rather than ultimate limit state of bending and shear. So a very important aspect of the slab design is serviceability, which we have to take into consideration carefully. Now slabs, due to relatively larger surface area as we discussed compared to their volume, are more affected by temperature, because you know that whatever be the effect of temperature, that directly get influenced by how much surface area is exposed to the weather conditions. So in case of slab, whatever be the volume of the slab, but you will be observing that surface area will be comparatively higher. So if surface area is more, then definitely temperature effect will be more, and ultimately it will be going to develop shrinkage stresses, and secondary reinforcement is required to resist these stresses. So later on we will be going to discuss what is the meaning of this secondary reinforcement. So shear stresses, if we talk, they are not such critical in case of slab, but in beams they are more critical. Now RCC slab, as we have discussed already, they may be categorized into two categories based on the way how they support the load on it. Now, very first type of slab which we later on we will be going to design, that is one-way slab, and another type of slab which is two-way slab. Now, first of all, let us understand what is the meaning of one-way slab, how it behave, and what will be the behavior with respect to the loads and movements in case of if the slab is to be designed as a one-way slab. So, one-way slab are those slabs which carries load on their shorter span. So you are well aware that if we are taking a slab, then it will be having two dimensions, so two spans we can say. One will be the longer span, other will be the shorter span. So when the load is directly carried by shorter span, then that type of slab is known as one-way slab. Now you can see from this diagram, here there is a support, one support, and another support, just like two brick walls. And when slab is placed on these supports, then you will see that it will be having a bending shape like this. So that means whatever the load, that load will be transferred uh, along the shorter span, and from this side it will be transferred on the shorter span. So longer span is free. So that means you will be able to understand that whatever be the deflection or bending due to the loads, that will be uh, predominantly greater along the longer side of the slab or longer span. So that's why we have mentioned here that one-way slab carries load on their shorter span. Now ratio of the longer span to shorter span, here we have to take into consideration. So here, if the ratio of span along the longer side, that means length of the longer span divided by length of the shorter span, is greater than or equal to 2. That means Ly is greater than Lx, where Lx is the shorter span, and on which the slab is supported, as we have discussed, which is required to transfer the load. And then this type of slab which is having ratio Ly by Lx greater than or equal to 2, that type of slab is known as one-way slab. Now bending, if we take bending, the bending will be along one direction, particularly perpendicular to the direction of the supported edge. Now these are the supported edge, and this direction is the perpendicular direction to the support edge. So bending will be predominantly along this direction. So that means what we want to say here, that if you are just placing a slab which is supported on two sides along its shorter side, then its behavior as we can see in this diagram, then this beam, this slab we have to design as a one-way slab. And you can easily understand that where we have to place the reinforcement so that this deflection can be removed. Now this will be the sectional diagram of the slab. It is a simply supported type of slab. You can see the both end they are having any brick wall type of support, and this rectangular portion is a slab, that is a one-way slab particularly. So this one-way slab, it is a simply supported type of slab. You can see there is a blue color line. It indicates the main reinforcement. So that means here you are supporting the slab, here you are supporting. So when you are providing reinforcement in this direction, so that reinforcement is basically the main steel or tension steel, we can say. So that means we have to design the steel along this direction. But as we have discussed earlier, that we have to provide distribution steel also. So distribution steel will be in the direction perpendicular. So this will be the direction in which we are providing the distribution steel. So one thing you have to take into consideration, that in case of one-way slab, we have to design the main reinforcement, but distribution steel is not required to take any bending stresses, but it is provided to take temperature type of stresses. So sometimes this distribution steel is also known as temperature steel. So you have to provide minimum steel as per IS 456. So that will be minimum steel will be termed as a distribution steel. So as we have discussed, main steel is provided along or parallel to the direction of span, that is between the supports. And the distribution steel is provided in a direction perpendicular to the main reinforcement. So again, if we go through this diagram, and then these black color bars which you are able to see, these are the distribution steel, and blue color bar, it is a main reinforcement which has to carry all the bending moment. Now let us discuss what is a two-way type of slab. So two-way type of slabs are those slabs which is supported on all of the four sides, but load is carried on and the load is carried on the both the spans. Yes, so that means slab which is supported on all the four sides and the load is distributed on all the spans. The ratio of longer span to shorter span here, Ly by Lx is less than 2. Again, where Lx is the shorter span and Ly is the longer span. Now, when this type of slab, you can see in this diagram, these are almost they are having equal span length, almost equal span length. So that means their ratio of one span to another span, that is Ly upon Lx, may be less than 2. So what you will observe, that since the slab is supported on all the four sides, so when load is coming on the slab, then slab the bending behavior will be similar to this diagram as here we can see. That means you have to provide reinforcement in both the directions. Now here we will be providing main steel in both the directions. That means this is main steel along one direction and this is also main steel on the other side. So no distribution steel is need to be designed, because you can see that bending is, if I say this is x direction or this is y direction, then bending is very much effective in both the cases. That means this load will give you a bending of the slab in both the direction. So we have to provide steel along the both the directions. As I discussed, that bending exists in both directions, and you can see here that here blue color as well as black colors, they steel, both steel are termed as main reinforcement, that is tension reinforcement. So we can say tension reinforcement along x direction as well as along y direction, or better to say that tension reinforcement along longer span as well as shorter span. So to resist these movements, the slab must be reinforced in both directions by two layers of reinforcement and that are perpendicular to each other.